wanted to clarify something pertaining to latent heat calculation. When a circuit, an electric circuit, is used to heat up a coil to calculate the latent heat of vaporization or latent heat of fusion of ice or fluids, respectively. So, I'd like to just state that it's supposed to be IVT equals ml, subscript F or subscript V, but in addition to ml, there's a small component of heat, a heating component as well, and that heating component is defined as H, and that is a reality. However, it's ignored in all equations. Please bear in mind it's ignored, and we assume negligible heat losses, and that's just the case for post-16 calculational analysis pertaining to latent heat of fusion and latent heat of vaporization. So what you need to realize is that in all cases it'll be IVT equals ml, IVT equals ml. Now, if in case you've got two separate circuits and you've got the same you've got different masses of the same solid or liquid, and you'd like to verify how far the latent heat of vaporization or latent heat of fusion is from the reference table value in order to ascertain as to how contaminated the solid or the fluid is, you'll have to take IVT. So you set up two circuits. You set up two heating coils with DC and ammeter, voltmeter, forward bias diode, and you run the circuit with mass 1 of that particular same and then a mass 2. You obtain values with voltage, current, and time, voltage, current, and time. And if the time is constant, then I'll let you know what you do in from there onwards. So you calculate the first power, second power, and the time will be constant. So you bring the time beneath here, and then you'll calculate the power differential, mass differential, divide the two, multiply by time, and then you get the latent heat of fusion. That'll be either more or less than the reference value in System International. So you'll be able to see how contaminated the ice or water is, depending on how far more or far less its latent heat of fusion or vaporization is from the reference value of pure deionized water. So that's that, and that's now I'm one step ahead. So this is latent heat standardized verification. It's not the so if you wanted to calculate for a single solid, it'll be IVT equals ml, and boom, you do a subtraction and substitution and rearrangement for L, and you'll get it IVT over M equals L. But when you're verifying the purity, yield, or purity of a fluid or a solid as for latent heat of vaporization or latent heat of fusion respectively, you'll have to set up two circuits, run the heating coil with different voltmeter, ammeter, with the same amount of time, with different masses of liquid or solids, and then you check how large or small the latent heat of fusion or vaporization is in comparison to the reference values in the published scientific database. So that's how you verify the latent heat of fusion or vaporization in experimental physics, and to qualitatively comment. It gives you the grasp to qualitatively comment on the purity, yield, or purity of a fluid or a solid that either vaporized or it fused. So thank you very much for watching this video. I hope you learned something today, and I hope I was able to bring you out of the box for this topic of thermal physics. And I hope you learned something today. If you've got any questions, please do not hesitate to get in touch with me in the comment section below, and I'll try my best to answer all of your queries, comments, and questions. Thank you very much. Take care. Bye now.